Hi there, the purpose of this video is to help you understand the OSI model and to kind of review and go over the OSI test. So your OSI test is available for you on Moodle. If you'd like to print this off, you just go out to Moodle, sign in, and the OSI model test will show up on my Moodle class right there, OSI model test. I put some other resources available for you just under the miscellaneous section of Moodle. So OSI model information, just a link. I did an OSI lecture for you to watch if that's how you'd prefer to learn. There's an online OSI model practice quiz that you can click on it and practice the quiz. But right now what I'd like to do is just kind of go over the OSI model test that you're going to be taking, or that you've taken and that you need a review on. So in order to understand the OSI model, you have to understand that what you have is a user that's communicating over a network to another user. So these are called hosts or end devices. So you have a host to host, it's communication. And you have a network. So the idea is to send a message from this computer to this computer over a network. And there's a lot of things that need to happen correctly for that to happen. So we'll kind of refer to this network topology from time to time when we're teaching the OSI model, just to help you understand it. So one of the things that is important to understand is the OSI model is cut up into layers so that you can understand it better, and depending on what you're doing for your job, you might work in one particular layer or another, or if you're troubleshooting a network, you have to understand all the layers. So an easy way to remember the OSI model in order is remember all people seem to need data processing. That tells you the OSI model in order from the top down. So all people seem to need data processing, and then this is the application layer. This is the presentation layer. This is session. This is transport. This is network, data link, and physical. So then I want you to give me some examples of protocols or technologies that deal with a networking model. So under application, don't tell me Chrome or Internet Explorer or something like that. I'm looking for actual technologies that exist at the application layer. So application layer protocols that have to do, for example, for email. If I'm going to send a message from, this is Bob over here that wants to email, let's say he's going to email Scott over here. He's got to have an email server set up. He's got to have an SMTP server, and he's going to have either a POP3 or an IMAP. So SMTP, that's Simple Mail Transfer Protocol. That's the email server. That's the protocol that sends the email to his server, and then SMTP transfers it between servers, and then downloading the email is POP3 or IMAP. So that's just one example of an application layer protocol. So you can do IMAP, POP3, those are email servers or email services. Another example that you guys are all familiar with is HTTP. That's a web, obviously. So HTTP, you can do HTTPS. There's other web-based services that you might have used in the past, something like a download file, you might use FTP. So those are other examples of application layer protocols, and there's a lot of them. So there's probably hundreds of application layer protocols that you can do. So another nice way to think about HTTP is the format of HTTP is HTML. So a lot of you have done HTML programming that goes along with HTTP. You can have an email formatted message. We also have encryption that happens at this layer. So there's a lot of things that happen at the presentation layer as well, but basically what it does is it gets the message ready to go out over the network. So as we work our way down from our application, ultimately we're looking to put a bit of information on a physical wire, so Cat5e, to get sent over a network that has to go through the wire all the way back up to the user that's using the application. So that's kind of a way to think about it. Start up here at the application layer with a message. Things have to happen to the message to turn it into a bit, gets sent over the network, the other computer receives the bit and then has to reassemble it to a message. So one other thing that I wanted to show you is there's a ton of information about the OSI model on the internet. So I already just opened up a wiki page that shows a lot of information about the OSI model and just the layers and all sorts of examples at the physical layer or the data link layer, the network layer, whatever you're talking about. So you can Google this type of stuff to help you learn it. It's probably more information than you need to have for this test here, but it's a good thing to think about as you're going out over the network, so that you can help understand what's going on with the data as it's being transferred over the network. So let's just kind of go through this real quick. So a session, online banking establishes a session. It'll time out your computer if you're not using. A couple minutes ago I logged on to Lake Michigan Credit Union. I'm not sure if it's going to have me log out or not yet. PowerSchool, well, the website will log me out if I don't use it. And then the online banking will also time out my session. I've been on it long enough where it hasn't timed out, but hopefully I'll look back here in a minute and we'll be able to see that I've lost my session. And then another way to look at sessions, if you just go to computer management and then just go ahead and open up your computer manager. If you have some file shares, on your computer, there's a area that will show who's connected to your network. So if this is a server, there would certainly be a lot of users on there. You can actually go on there and disconnect sessions, or if there's an individual user in there, you can individually disconnect people. But depending on the application that you're using, the programmers have to decide if they're going to terminate your session after a certain amount of time or not. So like an example of a program that never ends a session would be Facebook. You still have to log in, you still have to create a session, but Facebook will let you stay on basically forever. So session, it basically controls your connection to the computer. So you have to start a session and you have to stop a session. That would be fine. Start or stop a connection to a server. So start, stop's okay with my session. Encryption happens at the presentation layer. File formatting happens here. So I'm giving you a lot of different examples. You only need to come up with two. The transport layer, we have two basic transport protocols. One is UDP and one is TCP. UDP does not check for errors and does not correct. It just sends, kind of like fire and forget. So like telephones do UDP, and then an example of a TCP would be an email message. So if you send an email message and the part of the message gets destroyed, the TCP protocol will actually send the packet back that got dropped. So at the transport layer is the first time the segment or the network message gets segmented. So it gets divided up into parts. So if we look back here, if I'm going to send a message out, I'm going to write a big long email message. Say it's a 10 megabyte message for whatever reason, it'd be a big email, but it needs to be broken up into manageable pieces and it needs to be numbered. And then it's going to go out through the computer, through the physical, all the way through the network. And then when those little packets arrive at the receiving computer, they might come out of order, or they might be dropped altogether. So over here at Scott's computer, if the message comes to packet 2, packet 1, packet 3, and it completely loses packet 4, TCP will say, hey, resend packet 4. It'll go all the way through the network, and then Bob's computer will resend packet 4, and then it reassembles them in the correct order so that Scott can read his message. UDP doesn't do that. If it misses a packet or if it comes out of order, it's just too bad. So there's a lot of things to know about UDP and TCP, but just as an example, that's where the message gets segmented, and you have to decide what protocol you want to use, depending if you want error checking or no error checking. Network layer, if you've done some networking before, you've worked in the network layer, so IP addresses in there, so like IP4, subnets would belong there, a router would belong at the network layer. And then data link layer, that's where your switch belongs, your network card belongs there, MAC address belongs there. And then physical, all the things that you've done with cabling belongs at the physical layer. So Cat5e, bits, electricity. You can do light for fiber optic punch down block, your jacks. So there's examples of physical layer networking. There's also physical layer protocols that you could write in there. If we look back at my web page that I opened up earlier, there's some of your physical layer protocols that you might have heard of before. So USB, some of the radio signals, 568, 568B, what cable standard would be down there at the physical layer. So I had to write this test. People used to think that the object of the OSI model was troubleshooting. It's not. The purpose of the OSI model, if you look back at this page, is to ensure end-to-end communication over a network. So when I'm checking this question, I'm looking for end-to-end communication, and I'm looking for network. So the purpose of the OSI model is to establish or help or create a set of rules for end-to-end communication over network. 802s, all 802s are local area network standards. Can't just say network standards because there are wide area network standards, there's physical standards, there's all sorts of different standards. So basically they're layer 2 standards. OSI model is helpful to troubleshoot. This is really why I focus on the OSI model so much in my class, because I want you guys to have a framework to troubleshoot a network. So understanding the OSI model, it basically helps you pinpoint errors that are happening in the system, and once you pinpoint an error, it allows you to troubleshoot the problem quicker. It allows you to pinpoint the problem. So one way that we troubleshoot our network is we try to ping a device. If the device doesn't ping based on the message, you either work down to the physical layer, the data link layer, the network layer, or if the device pings but you can't send an email, you might work up towards the application layer, the session layer. Maybe they don't know their username and password. So that's really how it works. I like to start with ping. Ping's kind of in the middle of the network. So if I can ping Google, but I'm using Gmail to check my email and I'm not getting my email, odds are that you have a problem with the application layer or something higher. If you can't ping the resource that you're trying to get to, then it might be a physical problem, might be a routing problem, might be a switching problem, might be a VLAN, might be a bad cable. So understanding the OSI model provides a framework for troubleshooting to help you pinpoint. It helps you pinpoint where the problem will exist, and it allows you to get away from trial and error all the time to troubleshoot things. If you always start with a physical layer and it winds up being a bad username and password, you're going to spend a lot of time, troubleshooting cabling and things like that, when really it was only an application problem that you needed to check. Fixing a layer 1 problem, by now you guys have hopefully done some cabling in this class. So if sometimes people mix up 568, 568B, and they wind up making crossover cables, so just identifying that you miswired, or if you crossed one over, that would be fixing a layer 1 problem. If you had too much untwisted wire and you fixed a crosstalk issue, if you replaced a bad jack or a punch down block, or if the Cat5e cable was broken and you replaced it, those are the examples I'm looking for there. Routers read IP addresses. A router looks at a packet and makes decisions on routing based on the IP address. So if we want to go back up here and talk more about this, packets happen at the network layer. Here it's a frame. So, and here we have just a segment. The segment gets put into the packet gets put on the frame, and the frame gets prepared for transmission over the network, and it gets sent out as actual bits over the network. So in the packet we have an IP header, and that tells the computer or the router how to forward the information to the correct cable segment, or the correct network segment. Switches read MAC addresses, as do network cards. NIC is network interface card, it's a MAC address. To look up your MAC address and your IP address on a computer, what you do is you have to get to your desktop. I'm doing mine in Windows 8, so I just type CMD, get to my desktop, and I type ipconfig, and then you have to do a /all. Then just take a look at what you get. I always scroll back up to the top, and there is my physical address for my wireless adapter. It's a MAC address, and then my IP address is right here. So IP4 address 172.2640.5. So I would just write those numbers down for my answer. If you have a phone and you want to look at your MAC address, it's kind of a fun thing to look up. depending on what type of device you have. I'm going to do mine on Android, and if you were cool, you'd have Android 2. You just have to go to your settings, and it's pretty easy to find an Android under... Oops. Hey, by the way, there's my session. This is good that this happened, so I logged on at... They allow you 20 minutes here, so Lake Michigan Credit Union is getting ready to time me out, and the session layer is controlling that. Well, it's kind of ironic that that happened. I'm glad that happened. Click on Wi-Fi, and then I'm connected to the network right now, so at this point just go to Advanced, and there is my IP address and my MAC address. If you have a piece of fruit, otherwise known as an iPhone or an iPad, they have their IP address and their MAC address in a different place, but I can show you where to look for those if you want to use those. So there's a review for your OSI model test. Hopefully that helped you, and if you need some help studying, I'm happy to help you. You can study with your partners on your team. You also remember we have I have other information available for you in Moodle that can help you with your OSI model. So this is the OSI model test review, and hopefully you'll get 100% on it. Understanding the OSI model is very important for you to understand and troubleshoot networks, and you can use it all the time for if you're taking a Cisco test, or if you want to understand networking in more detail, you're going to need to understand the OSI model.